Good evening to one and all. Today we are going to discuss about 10th class chapter, that is chemical reactions and equations. Okay, here, what is a chemical reaction, sir? A symbolic representation of any chemical change in terms of reactants and product. Or what is the exact definition of chemical reaction? Whenever chemical reaction, whenever a chemical change occurs, whenever a chemical change occurs, takes place, we can say whenever a chemical change occurs, when we can say that a chemical reaction takes place. A chemical reaction takes place. Example, digestion of the food, rusting of iron, or one more definition, a symbolic representation of any chemical change in terms of reactants and product. Arrow mark left side substances are called reactants. Right side substances are called products. Simply, what is a chemical reaction, sir? A symbolic representation of any chemical change in terms of reactants and products is called chemical reaction. What is chemical equation, sir? A chemical reaction can be expressed symbolically, is called chemical equation. A chemical reaction expressed symbolically is called chemical equation. Or the equation in which number of atoms of various elements of the reactant side and the product side may be equal or may not be equal is called chemical equation. A chemical reaction can be expressed symbolically by using chemical equation. For example, if you take here chemical equation, now I am taking example here. What is the example for here? Now I am taking example. When a magnesium combines with oxygen, magnesium combines with oxygen to form magnesium oxide. We can observe in this equation, Mg is a symbol of an element, O2 is a chemical formula. We can observe or recognize a chemical reaction by observing change in a state. Okay, magnesium is a solid oxide, change in a state, color, evaluation of gas, or by changing its temperature. The physical states of reactants and products are mentioned to make a chemical reaction more informative. We use gases for G shortcuts. Okay, gas means small g, L means liquids, S means solids, aqueous, like that. Here Magnesium is symbol of element Mg. This is a chemical formula. It is also a chemical formula. Before going to chemical equation, what is a chemical change? The changes are classified into two types. How many types? Two types. That is physical and chemical changes. The changes are classified into how many types? Two types. That is physical change, and second one is chemical change. What is physical change, sir? What is chemical change? What are the characteristics of physical and chemical changes? Simply, the substance which can undergo change in size, color, state without formation of a new substance is called physical change. The substance which can undergo change in size, color, state, or without changing of new substance is called physical change. What is chemical change, sir? The substance which can undergo change in its molecular composition and formation of new substance is called chemical change. Example for physical change: melting of ice, solidification of ghee, what are the examples here? Melting of ice, cutting of trees, melting of ice, cutting of tearing of paper or cutting of vegetables, papers, etc. Example for chemical change: rusting of iron, burning of paper, digestion of the food, preparation of curry, etc. I hope it is clear. So what is the definition of chemical equation, sir? Chemical equation. A symbolic representation of chemical reaction is called chemical equation, or we can observe here chemical equation. The equation in which Number of atoms of various elements of reactant side and product side may be equal or may not be equal is called a chemical equation. These chemical equations are broadly classified into two types. Unbalanced chemical equation and second one is a balanced chemical equation. What is a unbalanced chemical equation? The equation in which number of atoms of various elements of the reactant side and products are not equal. The equation in which number of atoms of various elements of the reactants and products are not equal is called unbalanced chemical equation. It is also called skeleton equation. Skeleton equation. Example for unbalanced chemical equation here. Magnesium combines with oxygen, magnesium oxide. So take one more example. H2 plus O2 gives rise to H2O. Like that, if you take what is a balanced chemical equation, the equation in which definition of balanced chemical equation. The equation in which number of atoms of various elements of reactant side and product side must be equal is called balanced chemical equation. Why chemical equation must be balanced? Because of law of conservation of mass. The term law of conservation of mass was introduced by Anthony Lavoisier. The mass neither be created nor be destroyed in a chemical reaction. The mass neither be created nor be destroyed in a chemical reaction. The total mass of reactants becomes equal to the total mass of product. What is reactant, sir? The substance which take a part in the reaction, or the substance which can undergo chemical change in the reaction, or starting material is called reactant. The substance which can undergo chemical change in the reaction is called reactant. A new substance is formed in the reaction is called product. I hope it is clear. In case, what is the example for balanced here? Before Mg plus O2 gives rise to MgO. 2Mg plus O2 gives rise to 2MgO. 2H2 plus O2 gives rise to 2H2O. Like that, etc. I hope it is clear. What is a chemical equation? Classification of chemical equation. Right. Now, what is a word equation, sir? The chemical equation is written on the word form. The chemical equation is written on the word form is called the chemical equation is written on the word form. Word form. Word form means you can observe here. Now I am taking this is a conical flask. Take a few zinc granules. A conical flask. Add a few ml of HCl in it. What happened? To form a here evaluate gas. When a zinc metal combines with hydrochloric acid to form zinc chloride and hydrogen gas. Okay, the chemical equation is written on the word form is called word equation. The chemical reaction is written on the word form. Okay, what is the symbol of zinc? Zn. The chemical formula of hydrochloric acid HCl. To form ZnCl2 is the chemical formula plus H2. It is unbalanced chemical equation. How to identify whether it is balanced or unbalanced? Okay, to balance the chemical equation, now I am writing here element, number of atoms in reactant side, product side, or LHS side, RHS side. How many elements present here? You can observe zinc one element, hydrogen one element, chlorine. Total 3 elements are there. Reactant side, how many atoms are there? 1 zinc. Product side also 1 zinc. Reactant side 1 hydrogen atom. Product side H2 2 is next one. How many chlorines in reactant side? 1. Product side 2. You can observe here how to balance the chemical equation. Okay, in these 3 elements, which is a metal? Zinc. Already it is balanced. Hydrogen, chlorine not balanced. In case we can balance the hydrogen atom, step number 1. To balance hydrogen atom, coefficient 2 is added before HCl molecule on reactant side. In the side 2 is there, 1 2 is 2. Okay, now it is balanced. To balance the hydrogen atom, coefficient 2 is added before HCl molecule on reactant side. That means Zn plus 2 HCl gives rise to Zn Cl2 plus H2. 2 into Cl, 2 ones are 2, here also 2 is there. Now it is balanced. Like that we can balance any chemical equation. I hope it is clear. Okay, now I am taking one more equation how to balance the chemical reaction. Now I am taking one more example. Okay, how to balance the chemical equation. If you take one more example here. Now, C3H8 plus O2 gives rise to CO2 plus H2. This is the one of the chemical equation. First, identify the elements in the given equation. What are the elements here? Carbon, hydrogen, oxygen. Next, number of atoms. Number of atoms in LHS, RHS. How many atoms are there? Carbon 3 atoms in reactant side, product side 1 atom. 8 atoms here, 2 atoms. 2 atoms, 2 plus 1, 3 atoms are there. Now, which one is a balance? Not balanced. All are unbalanced. Reactant side atoms, product side atoms are not equal. The reaction which number of atoms of reactant side and product sides are not equal. It is unbalanced chemical equation. How to balance in this equation? First, now I have to balance step 1. To balance carbon atom. First carbon atom we should balance. To balance the carbon atom, coefficient 3 is added before carbon dioxide. Coefficient 3 is added before carbon dioxide on product side. Product side means this side. That's why here now I am taking example C3H8 plus O2 gives rise to 3CO2 plus H2O. Step 1 is completed. Step 2. Now you can observe here 3 carbons. Carbon atoms are balanced. Now 3 carbons. 3 2 is 6. 7 hydrogen. Here how many hydrogens are there? Now I am taking step 2 to balance hydrogen atom. To balance hydrogen atom, here how many hydrogens are there? 8 is there. In this side 2 is there. Coefficient 4 is added before water molecule. To balance hydrogen atom, coefficient 4 is added before water molecule on product side. That is step number 2. C3H8 plus O2 gives rise to 3CO2 plus 4H2O. And one more step is step number 3. Now you can observe hydrogen atoms are balanced. To balance oxygen atom. To balance oxygen atom, coefficient to balance oxygen atom, coefficient in the side 3 to the 6 plus 10 atoms are there. Coefficient 5 is added in the side, this side 5 to the 10. In this side how many is there? 10 is there. 5 is added before oxygen molecule on reactant side. That's why here C3H8 plus 5O2 gives rise to 3CO2 plus 4H2. So this is the balanced chemical equation. I hope it is clear. Like that in any example. Thank you. Good morning to one and all. Today we are going to discuss about examples of balancing chemical equations. Okay, for example, now I am taking here examples of balancing chemical equation. Balancing chemical equations examples. Actually, what is balanced chemical reaction, sir? The reaction in which the equation in which number of atoms of various elements of the reactant side and product side must be equal. Why chemical equation must be balanced? Because of law of conservation of mass. The law of conservation of mass states that the mass neither be created nor be destroyed in a chemical reaction. The total mass of the reactant is equal to the total mass of the products. Now I am taking one example here. When nitric acid combines with calcium hydroxide, so here to gives rise to form calcium nitrate and water. It is a one chemical equation. You can observe here number of atoms of reactant side and product side not equal. How to balance this equation? First to write the elements in the given equation. Elements and number of atoms in LHS side, RHS side means reactant side, product side. How many elements are there here? Hydrogen, nitrogen, oxygen, calcium. 4 elements are there. How many elements are there? 4 elements. Number of atoms in reactant side and the product side. Reactant side you can observe here 1 hydrogen, here 2 hydrogens, total 3 hydrogen atoms, here 2 hydrogen atoms. Nitrogen 1 nitrogen, taken twice means 2, here 1, here 2. Means reactant side 1 nitrogen atom, product side 2 nitrogen atoms. Oxygen 3 2s are here 3, here 2, 5. In this side 2 3 is 6, 6 plus 1 7. Calcium 1, here also calcium. Calcium atoms balanced, already balanced. Now we can balance the remaining elements. Okay, now I am taking nitrogen here. Step 1, to balance the nitrogen atom. To balance the nitrogen atom. Here how many nitrogens are there? 1 is there, here 2 is there. That's why suitable number is multiplying with the reactant side. That is coefficient 2 is added before HNO3 molecule on reactant side. That's why, what is the reaction here? 2HNO3 plus CaOH taken twice gives rise to CaNO3 taken twice plus H2O. This is first step. I hope it is clear. Okay, now you can observe here. Now I am taking in this equation. How many hydrogens are there here? 2 hydrogens. Here 2 is there. Total 4 hydrogen atoms in the reactant side. Here 2 is there. 2 to the 4. How many oxygens? 2 3 is 6. 6 plus 2, 8 oxygens are there. Product side, no? Yeah, 2 3 is 6 plus 8 here is there. 2 3 is 6 plus 1, 7 is there in this side. Next, step 2. To balance the oxygen atom, or if you take a hydrogen, to balance hydrogen atom, here reactant side 2 is 4 is there, product side, now I am multiplying 2. Coefficient 2 is added before water molecule on product side. Means here 2HNO3 plus CaOH taken twice gives rise to CaNO3 taken twice plus 2H2O. Now here 4 hydrogens, here also 4 hydrogen atoms are balanced. Now check oxygen atoms here. 2 3 is 6, 6. So 8 is there this side. Here 2 3 is 6, 2. Here also 8 is there. Okay, this is the final balancing equation. I hope it is clear. Okay, like that. Now I am taking one more example here. If you take one more example, now I am taking one more example here. Now I am taking one more example, that is sodium hydroxide NaOH plus H2SO4 gives rise to Na2SO4 plus H2O. Balance in this equation. What are the elements here? Sodium, sulfur, oxygen, hydrogen. Okay, how many sodium atoms are there? One is there in reactant side. Here two is there. Next, so sulfur atoms one. That side also, product side also one only. Oxygens here one plus 4 5 is there. Reactant side, product side also 5 is there. 4 plus 1 5. Hydrogen atoms 3 is there. Here 2 is there. Okay, this is a given information. Now balance the atoms. First these are sodium, sulfur, oxygen. Which one is first balanced, sir? Always metals are first balanced. Sodium is not balanced. That's why to balance the first sodium atom. Step 1, to balance sodium atom, coefficient 2 is added before NaOH on reactant side. Okay, that's why reactant side means this here 2, we will keep here 2. Okay, 2 NaOH plus H2SO4 gives rise to Na2SO4 plus H2O. Now you can observe sodium atoms are balanced, but here how many oxygens are there? Here 2 plus 4 oxygen atoms of reactant side and one sulfur only. Hydrogens 2 plus 2 4 hydrogen atoms are there. 2 into H 2 4 hydrogens. Oxygens here 2 into plus 4 6 oxygens are there here. I'm sorry, 2 plus 4. Only sodium atoms are balanced. Step 2. Now I am balancing here. Sulfur already balanced. Now balance the hydrogen atoms. To balance the hydrogen atom, here how many is there? 4 is there. Okay, that's why to balance the hydrogen atom, coefficient 2 is added before water molecule on product side. Product side means this here. We will keep here 2. What happened? Here, to balance the hydrogen atom, the coefficient 2 is added before water molecule on product side. This is the final balancing equation of this equation. 2 NaOH plus H2SO4 gives rise to Na2SO4 plus 2H2O. Like that. Now I am taking one more example here. Okay, balanced chemical equation means the equation in which number of atoms of various elements of the reactants and the product side must be equal. Okay, it is a hit and trial method to write the suitable coefficient on either reactant side or product side. Okay, if you take one more example here, that is now I am taking here odd equations. Odd equations like barium chloride. Now I am taking some examples here. that is barium chloride combines with potassium sulfate to form barium sulfate plus potassium chloride. Is the chemical equation. In this equation, okay, what are the here elements are there? You can observe elements, number of atoms in LHS side, RHS side. How many elements are there here? Barium, potassium, chlorine, sulfur, oxygen. 5 elements are there. Reactant side barium 1 is there. Product side also barium 1 is there. Reactant side potassium 2, but that side product side 1 only. Chlorine atoms, how many chlorine atoms are there? 2 chlorine atoms in reactant side, product side 1 only. Sulfurs 1, here also 1. Oxygens here 4, here also 4. Okay, barium atom is balanced and potassium and chlorine is not balanced. Okay, remaining all are balanced. Sulfur, oxygen, barium are balanced. Okay, remaining are not balanced. That's why here to balance the potassium atom, step 1. To balance potassium atom, how many atoms are reactant? 2 is there, product side coefficient 2 is added. Coefficient 2 is added before KCl molecule on product side. Product side. It's here equation. Barium chloride plus K2SO4 gives rise to BaSO4 plus 2 KCl. Now check the atoms. Barium 1, barium 1. First one is already there. Cl2 is there. 2 into Cl. It is also 2 is there. Potassium 1, sulfur 1 only. Oxygen 1. Like that to balance the chemical equation of various reactions. Hit and trial method. Number of atoms of various elements of reactant side, product side must be equal. Must be equal. If you take one more example now here. Now I am taking one more example. Zinc metal combines with silver nitrate, AgNO3 gives rise to, okay, now I am taking direct hit and trial method. Zinc nitrate ZnNO3 taken twice plus Ag. Okay, it is one equation. How to balance this one, sir? One potassium is there, one potassium. One silver. Nitrogen 2 is there. That's why now I am writing here. To balance the silver atom, coefficient 2 is added before AgNO3 molecule on reactant side. Then we can observe here zinc atoms 1, 2 Ag. Here we coefficient 2 is added before Ag on product side. 2AgNO3. ZnNO3 taken twice, 2NO, 2 3 is 6, 2 3 is 6, balanced. Like that, aluminum combines with copper chloride to form aluminum chloride and copper. How to balance in this equation, sir? Aluminum 1 is there. Copper also one atom reactant side and product side also 1 is there. But chlorine atoms are not balanced. That's why now I am taking here 3 2s are 6, 2 3s are 6. Chlorine atoms are balanced. But copper 3 is there. 3. Aluminum 2 is there. 2. Okay, 2Al plus 3CuCl. 3CuCl2 gives rise to 2AlCl3 plus 3. Like that, any chemical reactions by using of hit and trial method, a suitable coefficient is added before reactant molecules or product molecules. I hope it is clear. Now we will continue one more concept, that is types of reactions. Types of reactions, chemical reactions. The chemical reactions are classified into various types here. It is most important for long answer questions. It is very easy. Explain the following terms of chemical reaction. The first one, the chemical reactions are classified into various types. The first one is chemical combination reaction. What is chemical combination reactions? Are very easy. Okay, the reaction in which two or more reactants are combined to give a single product. For example, now I am taking A plus B gives rise to C. This is general form. The reaction in which single product formed from the two or more reactants. Examples. This is exothermic reaction. For example, now I am taking here. Okay, this is a magnesium ribbon. Magnesium is available in the thread form or strip of wire form. With the help of burner, what happens, sir? When a magnesium bonds with oxygen to form magnesium oxide, Mg plus O2 give 2Mg. First example, 2Mg plus O2 gives rise to 2MgO. Second example, carbon combines with oxygen to form carbon dioxide. One more example. If you take here, it is a beaker. Take a small amount of lime. Lime means CaO. Is added to the water to form lime water. In this lime water combines with atmospheric carbon dioxide to form a limestone. This is called a limestone. It is also called calcium carbonate. Okay, calcium hydroxide is also called lime water. Lime water. It is useful for the whitewashing of walls. Already you know whitewashing. Before paint, first coating is there. The first coating is called whitewashing. It is absorbing from the surrounding carbon dioxide to form calcium carbonate. These are the example for combination reaction. The reaction in which single products formed from the two or more reactants, or the reaction in which two or more reactants are combined to give single product is also called chemical combination reaction. Like that, so many examples are there. In case H2 plus O2 gives rise to 2H2O. N2 plus O2 gives rise to 2NO, etc. N2 plus H2 gives rise to 2NH3. These are all examples for combination. Any two examples is better. Okay, this is information about chemical combination reaction. I hope it is clear. Next we will continue one more classification, chemical decomposition reaction. What is it? Chemical decomposition reactions. Chemical decomposition reaction. Decomposition means AB molecule split into A plus B, or A gives rise to C plus B, or B plus C, anyone. Single substance split into two or more substances. The reaction in which single substance break down into or split into two or more substances is called chemical decomposition reaction. Once again repeat, the reaction in which two or more products formed from the single reactant is called chemical decomposition reaction. These chemical decomposition reactions are classified into three types. That is, the decomposition reaction is carried out by heating, is called thermal decomposition reaction. Okay, what is thermal decomposition reaction? Okay, the reaction in which single substance split into two or more substances. Okay, now I am taking here small experiment. This is a conical flask. Take a small amount of CaCO3. then heated strongly with the help of burner. This is a rubber cork, or if you take normal simply test tube, take a small amount of calcium carbonate in the test tube, then heat it strongly to be kept in a store. Here this is a delineate tube. This delineate tube is allowed to pass through the soap solution. Or if you take that means here CaCO3, which decomposes to CaO plus CO2. One example in the presence of sunlight. So take one more example. Second example, PbNO3 taken twice on heating PbO NO2 plus O2. It is also one more thermal decomposition example. And third example is ferrous sulfate, which can decompose to ferric oxide, sulfur dioxide, sulfur trioxide in the presence of heating. Very easy. The reaction in which single substance split into two or more substances in the presence of heating. The presence of heating is called thermal decomposition reaction. Or if you take one more example, either MgCO3 or ZnCO3 decomposes to MgO plus CO2 in the presence of sunlight. ZnCO3 decomposes to ZnO plus CO2, etc. These are all examples for thermal decomposition. Next one, second one is electrolytic decomposition. The decomposition reaction is carried out by electricity. For example, now I am taking here you can observe here, this is a plastic mug. Take one plastic mug. Insert the two graphite rods base of the mug. These two are graphite rods. It is connected to the 6V battery. Okay, one is a positive charge, negative charge. One is act as a cathode, another one act as an anode. Two boiling test tubes kept in a reverse position on the electrodes. Pour some water in it. Add a small amount of dilute H2SO4 solution to the water. Switch on the battery. We can observe here. Okay, one of the here bubbles are coming. Two gases are liberated. One is a hydrogen gas, another one is oxygen. That means here the water molecule by passing of current electricity through the water, the water molecule which can decompose to hydrogen gas and as well as oxygen, that is a 2:1 ratio. Hydrogen is 2 moles to volume of the more space occupied by the hydrogen gas, then followed by oxygen. Simply the decomposition is carried out by the decomposition reaction is carried out by electricity is called electrolytic decomposition reaction. And finally, one more classification of chemical decomposition: photochemical decomposition reaction. The reaction in which decomposition is carried out by sunlight. The decomposition reaction is carried out by sunlight. Is called photochemical decomposition. Examples: silver bromide, which can be decomposed to silver and bromine gas. 2AgBr can be converted into 2Ag plus Br. 2AgCl can be converted into 2Ag plus Cl. This is information about photochemical decomposition reaction. I hope it is clear. Here definition. What is the definition of electrolytic decomposition? Simply the decomposition reaction is carried out by the decomposition is carried out by electricity. That is the definition. It is clear. Now, one more type of example, one more classification of reaction: displacement reaction. Third one is chemical displacement reaction. What is chemical displacement reaction, sir? The reaction in which more reactive element which displaces to less reactive metal from their compound. What is the decreasing order of metals, sir? Potassium is greater than, sodium is greater than, calcium is greater than, magnesium is greater than, aluminum is greater than, zinc is greater than, iron is greater than, lead is greater than, tin is greater than, manganese is greater than, hydrogen is greater than, copper is greater than, mercury is greater than, silver is greater than, gold is greater than platinum. This is a decreasing metal. Okay, what is the definition of this one? The reaction in which more reactive element which displaces to less reactive metal from their compound. This is called chemical displacement reaction. Example, now I am taking here some 2 beakers. Now I am taking, this is a copper sulfate solution, 2 iron nails kept in the copper sulfate solution. What happened? Iron plus CuSO4 gives rise to, okay, the blue color solution of the copper sulfate can be converted into green color. Copper is less reactive when compared to the iron. Iron is more reactive than the copper. That's why it is easily converted, which undergoes displacement. One example. To take one more example here. Now I am taking here ferrous sulfate. This is copper sulfate. Second example, when 2-3 species of zinc granule is added to that. The zinc granule is added to the ferrous sulfate to form ZnSO4 plus Fe. The zinc is more reactive than the iron. So take one more example. This is a conical flask. 1 or 2 zinc granules. Add few ml of dilute HCl. What happened? When zinc metal combines with hydrochloric acid to form zinc chloride plus H2. It is also displacement reaction. Zinc is a more reactive than the hydrogen. Or some more example here. Fe2O3 plus Al gives rise to Al2O3 plus Fe. That's all. Okay, this is information about chemical displacement reaction. I hope it is clear. Next class we will continue remaining. Thank you.